Hello and welcome to Beginner JavaScript. Today I'm going to be setting up Jest as well as setting up the debugger so I can set breakpoints and step through my code in Jest. The first thing I'm going to do is install Jest. I'm installing it as a dev dependency, which is what the -d is. And that's going to list it here as a dev dependency. After Jest is installed, I'm going to add a new script called test. This is inside the package JSON in the script section, and I'm just going to put Jest in here. This will execute the Jest CLI. Now if I type npm run test, I should see that Jest executes. So you can see here that it's failing because there are no tests found. One thing I always like to do is keep my tests near the files themselves. It makes it just a little bit easier to find the files that Jest is going to be testing. This is in contrast to having a global test directory in the root. So if this was multiple levels deep, let's say like level 1, and I had a file.js in here, I'd actually create a test directory also in here. Let me clean that up. Okay, so I'm going to create a new file and I'm going to call it index because I'm going to be testing the index file. .test.js. I'm going to add a describe block. Okay. I can see that describe is not defined, and that is because ESLint is complaining. To quiet ESLint up, I'm going to add Jest to true just to tell ESLint that we are writing code in a Jest environment also. So now that the describe has stopped complaining, it should be giving a little bit better IntelliSense here. So another thing I'm going to do is I'm going to install as a dev dependency the Jest types. This is in the type scope, and it's just called Jest. This is a project that has a lot of different IntelliSense options. A lot of types for TypeScript, but it also works with any VS Code JavaScript project really well. So after installing that, now I can see the IntelliSense is a little bit more descriptive. As my describe, I'm going to tell it what file I'm writing a test for, and then I'm going to be creating a arrow function block within that. So I'm going to create my first test just to see if this runs. I'm going to see if 2 + 2 is 2b4, and this is one of the things that that the Jest types adds, is this type of IntelliSense. So I know what I want to look for is 2b, but it lets me scroll through and see all the different other options that I have. But right now I just want to say 2b. So I'm going to test my first test. Actually, I'll just call it 2 + 2 = 4. That's a little bit more descriptive. Now you can run npm run test or npm test because test is a special keyword for npm. Npm run test as well as npm test do exactly the same thing. So now I'm going to see, there it is. My test ran, 2 + 2 is 4. Here's the describe. that I wrote up here, index.js, and I have one test suite and one pass. Perfect. So now that I have that, I'm actually, instead of an index file, let's call it math. Because what I want to do is just create some basic functions for testing. So I'm going to say const, let's just say add x, y, x plus y. And I'm going to export add. Now I'm going to import it in my test. I'm going to import the add function from math. If I did that right, I should see the function. There we go. And so now I'm going to call the function. I'm going to use the 3 A's of unit testing, which is arrange, act, and assert. Arrange is where you're going to set up everything you need to run your test. So I'm going to say, I'm going to expect the value 4. My actual test run is going to be in the act, and then in my assert I can actually change this 2 plus 2 and the expected. Now the nice thing about writing it this way is that I can see the values that I'm expecting at the top. I can see where my actions are, and then all of my assertions should look pretty close to this, if not exactly like this. It should always be expect actual to be expected. There are a bunch of cases where this isn't going to be true, and that's okay. But for the majority of the time, I make an effort to make it look like this. I don't leave the comments in because it's just far too verbose. So let's see if this still passes. It does pass. This is great news. Now the next thing is going to be setting this up in the debugger. So if we open up my config file, you can see I can launch my current, I can launch the current program, but I don't have anything in here specific set up for testing. You're going to need to have 2 different configurations. One for debugging your program, and then another configuration for debugging unit tests. The configuration for this is a little bit complicated, and just to make sure that you're getting the latest version, I would go directly to Jest website, go to their documentation, and in the troubleshooting section, you'll find they actually supply a debugging with VS Code. Now there's a couple of different things, or a couple of different versions here. Let's see, oh, here it is. So if you're on Windows, you're going to want to copy the Windows version. If you're in Linux or Mac, you can copy this version. So this is the version that I'm going to copy. And go ahead and just paste that after the previous configuration. Let's see, why is this complaining? Oh, I copied too much. I'm just going to copy the configuration. Okay. There we go. So what this is doing is this is creating a new debugger called Debug Jest. If I hit my drop down, I could see it right here. And that's what I'm going to select. What it's doing here is you can see that it's going to run a node environment, passing it the flag, inspect break. It's going to give it the full path to the Jest binary. And that's the reason why these things are different for Windows. You can see they're pretty much identical. Actually, I think they are identical, except for this one line. So the Windows binary is in a little different path. It's in node modules just bin jest.js, whereas in Linux and Mac it's in this location. So that's the only difference. So now that I have the launch JSON set up, I should be able to go back in here, add a breakpoint on 7. You can press play here, or you can hit F5. I'm going to hit F5. And we're going to see if my breakpoint gets hit. So we can see here, I have a breakpoint set up here, but the debugger stopped on this line. This is a common thing that you're going to run into with debugging JavaScript applications. It's incredibly annoying to have this thing be on a different line than you set your breakpoint, but it's actually fairly easy to fix. So this is something specific to Jest. I found that it's because Jest runs inside of a Babel environment and not a native Node environment, at least not the current Node environment that we're running in. So even though this project isn't using Babel, I'm going to add a Babel RC file with retain lines set to true. And this Babel RC file is only going to be used during the Jest debugging. So now I can see when I rerun, when I hit F5, my breakpoint actually gets set on this line. And if I didn't have that, let's just say it was false and I hit play again, you can see that when it breaks here, when my breakpoint is set here, it actually breaks all the way up here. The only way to solve this is to set retain lines to true. Sometimes it helps to set the source maps to true, but so far all we need to do is set the retain lines. Also, I've noticed, open up your preferences, open settings, the JSON version, and set this. There are some weird things that the new JavaScript debugger isn't going to handle correctly. So until they fix those things, I'd recommend toggling this to true or false to see if that helps your debugging experience too. So the next thing I'm going to do is add an asynchronous function. And I can see that ESLint is complaining about the arrow here, the unexpected token. This is actually valid. It's just that the way that our ESLint is set up is it is set to ES6 is true, but we have to tell it what version of ECMAScript that we're using. The way we do that is in the ESLint configuring sections is the parser options. We're going to want to look for the parser options and the ECMA version. And we're going to want to use one of these versions. I'm just going to set it to 2020 because I'm just going to assume that whatever environment I'm running in is going to be the latest. So I'm going to say ECMA version 2020, and then I should be able to go back into my code, and I can see that the arrow function, it's no longer complaining about the arrow function. The only error I do have is that this value is assigned and it's never used, and that's just because I haven't exported that. So I'm going to go back in here into the math.test file, and I'm going to add my add async. going to go ahead and change this test to be a little bit more accurate. I'm going to copy pasta this. And I'm going to call add async instead of just add. Now I always do this just to make sure that synchronous and asynchronous code is working and that I can debug both because of those weird issues with the floating breakpoints. So here I'm going to say expect resolves to be 4. And the reason I'm using resolves is because add async returns a promise. So you can see here actual is actually going to be a promise. And to test a promise, the promise or the actual itself is not going to be 4. The value inside is going to be 4. So I have to say it's going to resolve. If it was going to throw an error, I could say it rejects. But I want to test the success state, which is resolves to be 4. So I'm going to just hit F5, run it again. I'm going to release that breakpoint, so I don't care about that. And I see this is always something weird in asynchronous tests. So you can see that the test is passing, even though I'm almost positive that it's not passing. So here we go. There's no way that this could ever be 999, but for some reason it's passing. And that's because, oh wait, here, where is it? There we go. So if I were to scroll up a little bit more, in my test, I could actually see that it was expecting 999 and it received 4, but I'm getting this unhandled promise rejection warning. This is one of the reasons why it's so hard, or why it's so important to actually fail a test before you pass a test. So this is an example where if I had just run this, I might not have ever caught that error. But now when I run it again, I can see that it has an unhandled promise error, and that's because what's happening is this code is synchronous, but this add async is asynchronous. So to tell Jest that this is actually an asynchronous function, there's a couple of things that we can do. Most common would be to just return your expected. So now things are actually working the way I expect them to work. Nothing's out of place. Expected 999, received 4. You can see I have a little caret right here. Okay, perfect. So I'm going to put this back in, and I'm going to run my test again. Okay, my test is passing. In all of my asynchronous functions, I always like to add this line, expect.assertions 1. What this is saying is that I expect there to be 1 test. And that's because there's a lot of reasons why your test could fail, especially if you have asynchronous code. But if this was never run, I should see that this will still fail. So another way that you could write this code is to say, so we'll return our actual, and because it's a promise, I can get the value out using .then, and I can say expect value to be expected. I'd actually probably write this a little bit differently so that actual could be here, and then I have my expect actual to be expected still. Let's run this again, pass. Let's check it out in the debugger. Okay, our actual is 4, and our expected is also 4. I can see 4 in the closure. So here's our actual, here's our expected. Okay, so that works great. Now, the reason why I have this up here is sometimes you're testing something, like let's say I was testing the catch case and I didn't have this. If I were to run this and I was expecting the catch to execute, I was expecting this line to execute, this actually never gets run. I can see that when I run the debugger again, my tests run, but this line never gets hit, but my tests still pass. And that's because this catch block never runs. So it executes as if it were running this. Of course, if I convert it to a then, it is going to pass. I mean, it is going to hit this line. Let's try that again. There we go, and it is going to pass. So I always put this up at the top, and then you can see if I have my test written incorrectly, where I wanted to test the catch value, but it never gets run. This should fail because this line never gets executed. So I should still have a failing test. Okay, perfect. And that's what I want. I want my test to fail when this doesn't hit. But that's the reason why I don't like to write tests like this, because they tend to be a little bit fragile. So this is a little bit better. Let me just undo everything. There we go. This is a little bit better because if I actually say rejects in here, which is similar to what I was catching before. Let's see, we should see that it's still failing on the assertion call, but it should also fail on the rejects. There we go. Received a resolved promise instead of a rejected. Okay, so this method is a little bit more foolproof. So this is one style I like to write with asynchronous. Another way is to just use asynchronous code itself. So I can just say, I could just add await here to make this entire function asynchronous. I'm going to add an await here. The nice thing about writing it this way is I don't need this return. So the other way is a little bit, I think, more fragile, just because you can forget to write this return and then have your test pass when it should be failing. So now that I'm awaiting this, it's no longer going to be a promise, so I can actually get rid of the promise here too. So I'm going to hit F5. There we go. My actual is 4. My expected is also 4. Perfect. So this should pass. Okay, awesome. One more thing I like to set up in my Jest debugging is to set up the Jest test coverage. And that's just as easy as setting a new script, so under scripts, test coverage, and then just add the flag coverage. So now when I run npm run test coverage, I should see a coverage report here. So now I can see that my tests pass. But the nice thing about this is it's going to tell me what I have and what I haven't tested. So we can see what this would look like if I didn't have unit tests on everything. So I'm going to run my test coverage again. And you can see here I've tested half of my functions, 80% of the statements. And that is going to output a new folder here, coverage. So because we have a new folder, I don't want to check coverage in. So I'm going to go ahead and say, I'm going to add my coverage folder here. I'm going to add my node modules. Make sure that that is, that both of those are ignored. And then let's see if I can open this in a web browser. So if I open up, so if you go into coverage, there's this lcov report directory, and you can open up the index file there. And the nice thing about this is going to give you a visual way of navigating through your code to see what isn't covered. So it looks like their browser isn't exactly perfect. You can see it's kind of highlighting the A and the S and the async. I'm not sure why it does that, but it does correctly point out that it's not testing my X and Y. So this is going to let me browse through all the files in my project and make sure that I have good coverage. It'll give me a visual way of identifying what isn't or what is and what isn't covered. Okay, that's awesome. Let's add that back. I'm going to run my test coverage one more time. I'm going to open up my browser again. And now we can see my statements are at 100%, branches are at 100%, everything's 100%. This thing here will tell you how many times each thing ran too. If I was to run 3 or 4 unit tests on this thing, you'd see this number go up. Actually, let's see if we can make that happen. So I'll just change this to 3 and 3 is 6. Can expect 6, 3, and 3. Open up the browser again. And yep, it ran this one twice. Yeah, let's clean this up. Okay, just one last thing I like to test. Let's convert this into an expression, and I'm going to hit a breakpoint here. I always like to make sure that my breakpoints don't just land in the code, but that they also trigger in the, or I mean not just in the test, but in the code itself. So I'm going to hit F5, and I just want to make sure that this breakpoint gets hit. Okay, perfect. So here's my X and Y. Excellent. So the settings that I was talking about earlier with the preview of the debugger, I believe this was causing an issue. I'm going to hit F5 again. Yeah. When that is set to true, you could set breakpoints in your Jest code, but the breakpoints, oh, actually, I can't even set breakpoints here either. Yeah, okay. So, yeah, I was noticing a couple of problems with this, which is why I had to disable the preview. So if you're watching this far into the future, maybe they fix this. But if you're having issues hitting your breakpoints, definitely toggle this thing. So this is one of the things that I need to test too, is to make sure that not just the code here that gets hit, but this actually gets hit too. So, okay, cool. So I can see, now I can see what happens if I were to mess with the value. I can see my test does fail. So that's perfect. Okay, well, that is how I set up my Node environment with Jest for debugging. Be sure to check out my other videos if you're curious about how I set up the environment, how I got Prettier and ESLint working, and how I set up the debugger also for not just for Jest, but for Node. And I'll include those in the descriptions. Be sure to leave a comment if you have any questions. Follow me on Twitter. My handle is @JoelNet. Ask me any questions about this if you're confused about anything. I'll try and help you out and walk you through whatever I've got. Anyway, so thanks. Until next time. Bye.